So the first thing that you need to know about functions is just the definition of a function. They're going to test that you know this definition in a few different ways. They'll never ask you to actually write it out, but they'll test to see if you can identify which relationships are functions and which ones aren't. So the important thing to note is that a function is a relationship between two variables where every input only has one output. Two inputs can share the same output, but for any one given input value, you can only have one unique output value. I'm going to write that on the board so you can get it in your note-taking sheet. And the way that they'll test this is through a few different ways. So they may represent a function as a graph, a table, a mapping, or a list of ordered pairs. And I'm going to show you an example of each of those. Before we go any further, I just want to show you what function notation looks like. So when you see it as an equation, any function, what they're going to do is write the name of the function. So for instance, the name could be f. The function would be called f of x. And in this case, you would see this on the left-hand side of your equation. And then the other side of the equation would kind of tell you the rule that governs how you get from input values to output values. So say, for instance, this were a linear function, we would have perhaps f of x is equal to 3x minus 1. And this would be the rule that relates inputs to output. Every input value would be plugged into there to get an output value. All right, let me show you the different ways that they're going to ask you about whether something is a function or not. The first way I want to look at is in tables. So when they show you a function in a table, they will always give you an input side, which will be x usually, and then an output side, which would be like f of x. The functions usually will have a letter name like that. Sometimes it'll be g of x, sometimes it will be h of x. This side of the table will have the input values. So say, for instance, we had 1, 2, 3, 4, and 5. And this side will have the output side of values. Now, if this is a function, you're going to expect that every single input has, its own output. So 1 would go to 3, 2 might go to 2, 3 might go to 1, 4 might go to 0, 5 might go to -1. And as you can see here, every single input has just one output. Now, the tricky thing about tables is that when an input has more than one output, when they're showing you an example of something that is not a function, what they're going to do is just list one of the inputs again, right? So for instance, this table is showing that the number 1 can either have the output of 3 or it can have the output of 2. And it may look like, oh, well, the thing that's actually repeating is an input, but it's actually showing you that the same one value can have 2 different outputs. Now, a way that they'll try to trick you is they will, instead of doubling up an input, they'll double up an output. So say, for instance, we had something like this. It may be tempting to think that this is not a function because you see 2 of the same outputs, but in reality, 2 different inputs having the same output is fine. It's just the fact that each one of these has only one output. There's no repeated input that has 2 different outputs. Another way you're going to see functions tested is on graphs, and there's a really easy test to tell whether something on a graph is a function or not. So let me show you an example. Say, for instance, on this coordinate plane, we have a function that looks like this. I haven't really sketched it correctly, but it looks something like that. Now, in the future, you'll learn about this function. This is a variation of a sine or cosine curve, but you don't need to know that right now. All you need to be able to do is identify whether or not it's a function. Again, we're testing, does every single input value only have one output value? And in this case, it does, and the way we can tell is through the vertical line test. Wherever I draw a vertical line through this function, I'm only going to pass through the function once, right? I pass through it over here, I pass through it over here, but there's no spot where I could draw a vertical line where I would pass through the function more than once. So this is a function. On the other hand, consider if we had a circle graphed. So we have our coordinate plane again, and we have a circle, right? If I were to draw a vertical line through the circle, I would actually pass through the circle twice, once over here and once over there. So this is not a function because it does not pass the vertical line test. Okay, Let's look at functions as a list of ordered pairs. And I'm actually going to use one of the examples from your note-taking sheet. So we're kind of skipping ahead and we'll come back for domain and range. But let's look at number 3. So this asks about different relations. And I don't really want to copy out all of them, so I'm going to give you a freebie here and show you one that is a function in this list and the one that actually isn't a function, so I'll give you the answer. So for instance, if we look at number 3, answer choice A is a function. So we have this list of ordered pairs 2, 4, 1, 2, 0, 0, -1, 2. I ran out of space, but I'm going to continue over here, and -2, 4. And what we see is that every single input has a unique output, right? There's no repeating inputs. There's no input that happens twice with different outputs each time. So this is a function. On the other hand, letter D is not a function. So let me show you what that one looks like. That has ordered pairs 2, 2, 1, 1, 0, 0, 1, -1, and 2, -2. So as you can see, there's actually a couple of them where the same input, so for here, 2, has 2 different outputs. Here its output is +2, and here its output is -2. Remember, with ordered pairs, the first number represents the y and the second the first represents the x and the second represents the y, which is the output. So here we've got input 2 getting +2 output, input 2 getting -2 output, again, not a function, and then we also have +1 having an output of +1, and then +1 having an output of -1, so not a function. You may also see mapping, but this is pretty similar to a table. This hasn't shown up on the Regents in a while, so I'm not going to emphasize it too much, but you would have your input values here, so say like 1, 3, 4, 9, 12, and your output values here, say 2, 4, 7, 6, 3. And what's important is that you don't see any input value going to 2 output values. Like anything like that would make this not a function. Whereas on the other hand, it's okay if 2 of the same inputs go to the same output, right? As long as there's only one line branching off from each of these input values, we're good. So I could fill in the rest of this. Maybe this would go to 2, this would go to 4. This is still a function, even though there's this lonely number 3 over here. It wouldn't matter. This is a function because each of my input values only has one line coming out of it, one output. All right, let's take a look at domain and range, and that'll be the last thing we do in this video. And then for the rest of our note-taking sheet with types of functions, I'll make a second video. So domain and range relate to our input and output values. The domain is just the set of all of the input values in our function, and the range is the set of all of the output values. So just if you wanted to take notes on that, under domain, you're going to put that it is the set of all input values, and you know that this relates to the x variables. So all input values, x variables, and if you're looking at a graph, you're looking how far left and right your function is going. So I'm going to put left and right. All of this is relevant to put into your note-taking sheet under domain. And then under range, we are going to say that it is the set of all output values and it relates to the y coordinates, the y values, and finally we would be measuring how far up and down the graph of our function goes. Okay, now there's a few different ways we can represent domain and range, but let's consider those 4 different ways we saw functions represented: through tables, through graphs, through sets of ordered pairs, and through mappings, where we draw the lines. In tables, right, it's pretty easy to recognize what's the domain and what's the range, because in a table you would actually have your x and then your f of x on the other side. So all the values underneath x would be the domain, and all the values under f of x would be the range. And the way that you could write them would simply be to just use set notation. So you could draw the squiggly line, list the numbers, and then end it. And that could be domain. You do the same thing for range. You don't need to know how to write that out. You just need to know how to identify it. You could also do this same thing for a mapping, right? For a mapping, you would just list all the input values in one of them and all the output values in the other one. Same thing. But for graphs, we're going to have to be a little bit more careful about how we're listing the domain and range, because there isn't like a set number of values that you get from a graph, right? Okay, say for instance, you have a function that looks like this. I'm going to draw a parabola. You may remember that this is the graph of a quadratic function, which is anything with an x squared in it as its highest exponent. If we wanted to talk about the domain of this, you can see that we've got these arrows on the end of our parabola. Now, they're starting to go up pretty steeply, but those arrows mean that they're going to continue in those two directions forever, and so there actually isn't really a limit for all of the x values we could have. It's going to eventually hit all of the x values, right? Because it's just extending outward and outward and outward as it goes up and up and up. So our domain would actually be from negative infinity all the way to positive infinity. And the way we would write that is most easily with interval notation, which means we're just going to write that it goes from negative infinity to positive infinity. The range of this is a little bit more involved because we actually do have a minimum value here. Let's say, for instance, this is at -1. So the range would instead go from -1 all the way up to infinity, because it actually can go all the way to the infinite y values. The arrow means it keeps going up and up and up. Now, you may notice that I've drawn a square bracket here. As a quick review, the square bracket means that it actually touches that value, whereas we always have to use a round bracket with infinity because no graph can actually ever touch infinity. It's just a concept, right? Infinity is something that can never be reached, so we always use the round bracket for that. So that's domain and range. And you can practice finding the domain and range of the ordered pairs that are some of these practice questions here, but I would just go through all the practice questions, do them as instructed in each of the problems. And if you feel confident in those, then you know you're solid on the questions where they'll ask you about the definition of a function.